Try to measure the diameter and radius are easy. They are just straight lines you can measure with a ruler. But to get the circumference, you need to measure in tape or a piece of string, unless there was a better way. Now it's obvious that a circle's circumference will get smaller or larger along with its diameter. But the relationship goes further than that. In fact, the ratio between the two, the circumference divided by the diameter, will always be the same number, no matter how big or small the circle gets. Historians aren't sure when or how the number was first discovered, but it's been known in some forms for almost 4,000 years. Estimates already appear in the works of ancient Greek, Babylonian, Chinese, and Indian mathematicians, and is even believed to have been used in building the Egyptian pyramids. Mathematicians estimated by inscribing polygons in circles, and by the year 1000, it has been calculated to as far as 10 decimal places. So when did they finally figure out the exact value? Instead of just estimating, actually never. You see, the ratio of a circle's circumference to its diameter is what's known as an irrational number, one that can never be expressed. As a ratio of two of the whole numbers, you can come close, but no matter how precious the fraction is, it will always be just a tiny bit off. So, to write it out in a decimal form, you have an ongoing series of digits starting with 3.14159 and continuing forever. That's why instead of trying to write out an infinite number of digits every time, we just refer to it using the Greek letter pi. Nowadays, we test the speed of computers by having them calculating pi, and quantum computers have been able to calculate it up to 2 quadrillion digits. People even compete to see how many digits they can memorize, and have side records for remembering over 60,000 of them. But for most scientific uses, you only need to remember the first 40 or so. And what are these scientific uses? Well, just about any calculations involving circles, from the volume of a can of soda to the orbits of the satellites. And it's not just circle, either because it's also useful in studying curves. Pi helps us understand periodic or oscillating systems like clocks, electromagnetic waves, and even music. And if that weren't enough, pi is used in particle physics experiments, such as using the Large Hadron Colliders, not only due to its round shape, but more subtly because of the orbits in which tiny particles move. Scientists have been using pi to prove the elusive notion that light functions as both a particle and an electromagnetic waves, and perhaps most impressively, to calculate the density of our entire universe, which by the way still has infinitely less stuff. Its total number of digits is way smaller than pi.